Dear, in this video we are going to discuss about measurement of uh, flow, that is flow measurement using four different equipments, namely venturimeter, orifice meter, rotometer, and pitot tube. These all the four instruments are used to measure the velocity of the flowing fluid. They are using the concept of continuity equation and Bernoulli's equation. The continuity equation, we are seeing that when the cross-section area decreases, velocity increases. That is continuity equation. Whereas the Bernoulli's equation, if the speed or velocity increases, the pressure drops. Based on this concept, the venturimeter is working. That we will discuss. As I have told, there are four different equipments are used for measuring the flow: venturimeter, orifice meter, rotometer, and pitot tube. Now look at the picture of venturimeter. The venturimeter consists of three parts: converging part, that is the area decreases, and throughout the area remains the same, that is the diameter remains same, and diverging part, the diameter increases, that is cross section of the diameter increases. This venturimeter is connected in the pipeline where the flowing fluid is passing, and we are going to measure the pressure at 2 points. One is at throat, another one is at the main pipeline. The purpose of keeping converging, throat, and diverging three components is to measure the pressure difference across the fluid flow. The converging part is used to increase the velocity, that is when the cross-section area decreases, the velocity will increase. That is continuity equation, that is known for everyone. That is when the cross-section area decreases, the velocity will increase. Okay, that is converging portion. So the velocity increases and the high velocity fluid is passing through the constant area, that is throat, where the diameter is the same, and it enters the diverging portion where the velocity will, that is where the pressure will be reduced. That is to compensate the portion of the converging, we have the diverging portion to maintain to recollect the pressure drop. In the converging portion, we have a diverging portion. That is the important point we have to understand. So the converging part pressure drops, whereas in the diverging part pressure increases. So the drop in pressure in the converging portion is compensated by providing diverging portion. That point we have to understand. That is the basic principle of working of venturimeter. The discharge can be measured using the formula coefficient of discharge into A1, A2, that is area at point 1 and area at point 2, root 2GH divided by square root of A1 square minus A2 square. So the manometer is connected between point 1 and 2, that is at main pipeline and at throat. So using this pressure difference, we can calculate the flow rate of water flowing through the venturimeter or in the pipeline. CD is the coefficient of discharge. It is normally 0.95 for venturimeter, whereas it will be low for orifice meter. So this is the working of venturimeter. So I hope you would have understood clearly. Next, we will go to, yes, as I have told, the converging portion pressure drops. Pressure is constant at throat. Again, pressure is increased at diverging. Advantages, we can have this for small head, no wear and tear, and disadvantage is long laying length. More space are required, quite expensive for installation and replacement. Next, here we are seeing the orifice meter. The orifice meter, it is also working on the principle of Bernoulli's equation, Bernoulli's theorem. Pressure drop is proportional to the square of cross-section area. So the orifice plate, the plate will be having that one end is circle, another end is also circle, but converging portion will be there. And as we have seen in the venturi meter, two ends are connected to manometer and we will be measuring the pressure. When velocity increases, the static pressure, that is after the orifice plate, the flow after the orifice plate, that static pressure will be reduced. This is working the principle of differential pressure. This is a device to determine the flow, and it has a fixed concentric pipe. That is, the diameter is gradually decreasing at on one end. The coefficient discharge is 0.6 to 0.65. It is like it will look like a washer, that is a circular plate with a sharp edged circular hole called orifice. Like a washer, but sharp edged circular hole will be there. That sharp edged circular hole will play the role of orifice meter. That is very important. Initial cost easy for installation and replacement also easy. Loss of head high, coefficient discharge is low, and it may undergo erosion. Third flow measuring instrument is pitot tube. Pitot tube in aircraft, you might have seen two sharp edged rods are coming out. That is to measure the velocity. One end of the pitot tube is connected directly to the measuring liquid. Another end is connected to the outer layer of the tube. The pressure difference will be measured. Here the static pressure, dynamic pressure, and stagnation pressure, these are the important three terms you got to understand. Static pressure means it is a constant, whereas the dynamic pressure is a varying. Stagnation pressure is the sum of static and dynamic pressure. If you look at the sketch, over the pipe, a piezometric pipe is connected where we can measure the pressure, that is the static pressure can be measured. Another end of the tube, that is pitot tube, is connected across the flow. It will touch the flow and pressure will be measured. That will give you the dynamic pressure. It should be more than static pressure. By the difference between these two, by using the calculation, we can easily calculate the flow rate. This also working on the principle of Bernoulli's equation. That is, static pressure plus dynamic pressure gives the stagnation pressure. This is working of pitot tube. Advantage is cost effective, no moving parts, simple to use and install. The disadvantage is the foreign material can clog the pitot tubes. The application, it is employed in variety of flow measurement and Air Force fighter jets we can have for measuring the speed, airspeed. Last one is rotometer. Area changes and flow rate changes. That is the concept here we have. Here we are having the float of varying cross section. That's why it is called as a variable flow meter. The float is heavier than the liquid, much heavier than the liquid, and density of this fluid is very high compared to the fluid or liquid which is flowing through this. It will move up, it will be kept always in the vertical position. The fluid will move up against the gravitational force, and at one state it will be stable. That measurement will give you the equilibrium. That can be measured, and we can calculate the flow rate by using the formula CA square root of 2G PD at divided by density. This is the rotometer. Direct visual indication on a linear scale. That is the advantage of rotometer. Very high accuracy, low cost, no external power or fuel. The limitation is due to its use of gravity. Rotometer must always be kept vertical. That's the drawback. Application: it is used in laboratory testing and production lines. It can be easily integrated with instrumentations like alarm indicators, controllers, and recorders. I hope this video helps you to understand various flow measurement devices. Thank you.